Now, in the last part of my talk, I'd like to discuss a few practical recommendations for those of you considering the use of AI-assisted data extraction. As you may know, several systematic review platforms are currently developing their own AI-assisted data extraction tools. And once these tools are fully integrated and validated, they could greatly enhance the efficiency of data extraction using one of the systematic review platforms. To my knowledge, however, no validation studies have been published on any of these tools, but such studies are really important because they show that these tools actually work. So it will be necessary that they publish these studies. Additionally, I think it's currently still unclear whether these new tools then allow customization of the underlying prompts, because what we saw, carefully fine-tuning the prompt is really critical to achieving accurate data extraction. But for now, commercially available large language models outside of the review platforms perform really well if users have expertise in prompt engineering. And in the following slide, I will share some basic recommendations for prompt engineering, specifically for data extraction. So important is really that before beginning any data extraction with a large language model, we found it really essential to clearly define every data item right from the start before even doing any prompt engineering. So we always created a structured list that clearly defined each data item. So for example, here we defined mean age as the average age of participants in years, including the standard deviation when reported. And so explaining the content and defining the content of a data item is important, and you should do it just as you would to a student who has never done any data extraction before and really does not know how much detail is expected. And additionally, before starting your data extractions with a large language model, make sure that you select a model with a large enough context window to handle the PDFs that you plan to analyze. But when you are done with all of this preparatory work, you can begin prompt engineering. And prompt engineering simply means creating instructions so that the large language model understands what exactly you want it to do. And good prompts are clear, they're direct, they are unambiguous. And it's important to remember that prompt engineering is an iterative process. So prompts often need several rounds of testing and refining before they then actually produce accurate and consistent data extractions. And we usually use 2 or 3 example articles to refine the prompts at the beginning. And when creating effective prompts, we found it helpful to structure them in 3 parts. So first, define a role for the large language model. So for example, you are an expert systematic reviewer specializing in data extraction from academic documents. Second, explicitly state the task, such as your task is to carefully read the academic document and extract specific data items. And then lastly, provide detailed instructions on what exactly the model needs to do and how you want the extracted data to be presented, so in tables, in bullet points. So for example, you could say for each data item listed, extract the information accurately. If an item isn't mentioned, recorded as noted, recorded as not reported. And then you just add on to the list of instructions, and then at some point you have to provide also the data items you wanted to extract. And such a structured approach really helps guide the model, resulting in more accurate data extraction. When you ask the large language model to perform more complex tasks, then consider using a technique called chain of thought prompting. This approach guides the model then clearly through each step it needs to take. And Anthropic, the creators of Claude, recommend explicitly instructing the model to think step by step. So for example, if you want the model to calculate standard errors from confidence intervals, a prompt could look like this. So if a standard error isn't reported, calculate it from the confidence interval of the effect estimate, think step by step before performing the calculation. And now you list the steps. So first, determine whether the effect estimate is a mean or a ratio. Second, if it is a ratio, convert the effect estimate and the confidence interval to natural logarithms. And third, calculate the standard error from the confidence interval. And you typically don't need to provide formulas. The models usually retrieve these independently. A really handy practical resource is Anthropic's Prompt Builder. This tool helps you either develop prompts from scratch or improve your existing ones. And Anthropic also provides a helpful prompt library and also interactive courses to build your prompt engineering skills. And if all goes well, you will get a clear and structured output like this, nicely summarizing all the data you intended to extract. And one last note of caution, human oversight really remains essential. So as a reviewer, you are ultimately responsible for the accuracy of your data. And to illustrate why oversight matters, try asking your language model to visualize an empty room with absolutely no elephant in it. And you will likely end up with something like this. And you then probably find yourself wondering, why is there an elephant in the room? And when I asked DALL-E about this, it explained it. It started quite politically correct, saying that that DALL-E doesn't inherently favor elephants over other elements. But then it explained that the metaphorical context of elephant in the room can ironically prime the model to visualize precisely what you tell it not to do. And this example simply underscores why careful human oversight of AI outputs is really always necessary. So, in conclusion, our findings show that large language models can indeed improve both accuracy and efficiency in data extraction. With appropriate prompt engineering, I think it is feasible to replace one reviewer for the initial data extraction phase. But again, human oversight remains essential for ensuring reliable results. Finally, I would like to acknowledge and thank my colleagues at RTI International, Cochrane Austria, and all our colleagues from the other five US evidence-based practice centers for their really important contributions to the SWA that I presented today. So their work made this research possible.